Question 6. Given that 0 is less or equal to x, which is less or equal to pi. Remember, pi is 180. Find the values of x for which one sine 3x is equal to 0.5. Now 0.5 is the same as half. So we like dealing with half. And so your x must be between 0 and pi. But we know that if we let theta to be equal to 3x, then we'll deal with sine theta is equal to half. But we know that angles between 0 and pi, that gives us half for sine is 30. So theta is equal to 30, meaning pi over 6. So how do you know that I must present my answer in pi's or in degrees? You look at the range given where your x falls. It can be x, it can be alpha, it can be beta, it can be omega, it can be theta. Those just represent the angle. So now, if the interval is given in radians, you must present your answer in radians. If the interval is given in degrees, you must present your answer in degrees. So now we've let theta to be 3x, and so sine theta is equal to half, meaning theta is equal to 30. Now remember, our answers must be between okay. It's a request that you should repeat. We haven't even gone far. So we are saying, if the interval is given in radians, we must present our answer in radians. Now, because we have sine 3x is equal to half, we are saying, if we let theta to be equal to 3x, that's the first thing. Then sine theta is equal to half. In that way. And then, if sine theta is equal to half, we know that the theta that gives us half is 30. Now 30 in radians is pi over 6. But remember, theta is 3x, meaning that 3x is pi over 6. So you divide by 3, you divide by 3. So x is equal to pi over 18. Now it's possible that if we get another angle that gives us positive half for theta, for example, which angle gives us half in the second quadrant, where sine is also positive. So since we are dealing with 30 here, we'll say 180 minus 30 is going to be 150. Then we convert 150 into radians. So you have 3 there, 5, 3 here, 6. So we have theta is equal to 5 pi over 6, also gives us half. But now theta is 3x. So again, we have 3x is equal to 5 pi over 6, meaning x is equal to 5 pi over 18. Okay, so far we have x is equal to pi over 18. We have x is equal to 5 pi over 18. We still have some other values of x that will fall within 0 and pi. So what do we do? Remember, the quadrant is here. We are dealing with 30. This is 30. If you start from here again, you go around, there's an angle that gives us the same half in the first quadrant. And that angle is 360 plus 30, which is 390. Now 390 is theta. but theta is 3x. So 3x is 390. Divide by 3, divide by 3. So we get x is equal to, what do we do? Let's convert it. Let's have it converted in, that is 2 pi plus pi over 6. That is 13 pi over 6. Okay, so 3x is equal to 13 pi over 6. Divide by 3, divide by 3. So x is equal to 13 pi over 18. So we have x is equal to 13 pi over 18. It's possible that if we go around again, you start from here, go there, get there, go around, you again get another angle that can give us sine that angle will be half. Meaning we add now 390 plus 360. So we are saying 390 plus 360, you get 0, 5, 750. We divide this guy by 3. Let's see if you get between 0 and 180. This will be 3 there, 25. This is beyond the required coverage. Okay. So 3 here, 1. Okay, so this one was okay. So this is beyond coverage. So the mind is blown, Excel. Don't worry. So this is, I think these are enough. You can just present even 3 of them, it's okay. But there might be another one in the second quadrant that will act the same way as this one in here. So you can, there's a hand from ZDM. That's the name showing here. So we start with ZDM. You can ask. Okay, Geoffrey. Is it Godfrey? Godfrey can ask.
Sir, the question is telling us to find the angles, the values of x between 0 and the pi, which is 180. But how come we've gone beyond 180 to go?
We haven't gone beyond 180. The angles we have, this guy here is less than 180, less than 180, less than 180. Remember, whichever angle that you find, you must divide it by 3 for you to get x. So you can go beyond 180. For example, when you divide by 3, it will come below 180.
Oh, okay.
Yes. Chanda. The hands which are not talking. How did the 13 pi come about? 13 pi, we changed 390 to radian. So we're saying 390 multiplied by pi over 180. The first thing is that the zeros will cancel. 3 in 39 goes there 13 times. 3 in 18, 6 times. That's how the 13 pi came about.
So,
Hello.
so I'm asking, I saw a similar example in pure and applied. It had 6 solutions. So like this, the same question came in our test too. So I'm asking, were you marking all the 6 solutions or you only supposed to show 2?
We're just marking for 2. If those 2 are correct, we marked it. We gave it full marks.
All right, thank you.
Okay. Okay. Next question. Is 2 tan x plus pi over 2 is equal to 1. Musa.
Yes, sir. So sir, in that case, if you had no 3 in front of x, so would have just presented the answers like in the first quadrant, would have just presented it like pi over 3, right?
Pi over
6,
6,
right?
and 5 pi over
And the
6.
5 pi over 6.
Yes.
If we never add the 3, right?
Exactly. So,
Okay. Thank you.
I think in the last class, we did an expansion of tan x plus pi over 2, where we said tan A plus B is the same as tan A plus tan B over 1 minus tan A tan B. This implies that tan x plus pi over 2 is equal to tan x okay, let me continue. I see what I wanted to write. Tan pi over 2 over 1 minus tan x tan pi over 2. I don't know why I'm writing this thing. Okay, so if this was to be 1, from there, it would mean that what is tan 90? Everything can be simplified, yes. Tan 90 is sine 90 over cos 90. But this guy is undefined. So we forget about that change. So we don't change it this way because we'll be stuck. So what we do is we get it the way it is. X plus pi over 2 is equal to 1, and let theta to be x plus pi over 2. And so we deal with tan theta is equal to 1, where we know that theta is equal to 45. So we change it, don't worry, 45 is pi over 4. So we are doing pi over 4. Since it must be in the first quadrant, I mean, it must be from 0 to 180. Then we are saying x plus pi over 2 is equal to pi over 4. So we are solving for x, so you would say x is equal to pi over 4 minus.
So,
Hello.
I've got a suggestion.
Suggest.
Yeah, so what if we let x plus pi over 2 equal to 5, then we calculate for 5, then later on we equate to x plus pi over 2. Right, tan inverse of 1, it will give us 45. Then we also find the quadrant. Yes.
Exactly where we are, is it? Or before we start converting, we also find something in the third quadrant where tan is positive. Okay, let's get there.
Yes,
so in the third quadrant, we have theta is equal to 25. Since we said you, how do we get the thing in the first quadrant? We said theta is x minus 180. Now we have theta. We're looking for x. So theta is 45 is equal to x minus 180. So x is going to be 45 plus 180, which is 225. So 225 converted in radian. What does it become? The converter has to convert. Okay, since converting will take us long, we'll just add pi over 4 plus pi. That's 5 pi over 4. So it's 5 pi over 4. This guy is just 5 pi over 4. Okay. Then, so far we have two angles. So we get to x plus pi over 2 and equate it to pi over 4. Now we are getting pi over 4 is equal to minus pi over 2. This guy will give us negative, let's see, 4 down, pi minus 2 pi, which is negative pi over 4. It's negative, but our answer must be between 0 and pi. So what do we do? Don't worry, you just look for the coterminal angle of this guy. It will still make sense. What is it to be in there? Between 0 and the. So the coterminal angle of this guy, we said if the angle you have is negative, you get it to positive by adding 360. So we'll add this to the guy. So we'll say 360 minus 45. This is 315. 315 is far away from the positive term. So this guy is not done that they're looking for. So we'll come round. So we'll go around like what we did here, where you do 2 circles. So what we'll do is, I'll do it from here. So say since we have where's 225? 225 is here. And then when we came this way, it didn't make sense. So come this way and come all the way up to there. Meaning 225 plus 360. That would be 225 is 5 pi over 4 plus 2 pi. Plus 2 pi. So over 1, so we have 4, 5 pi plus 8 pi. This guy is giving us 13 pi over 4. So we are saying x plus pi over 2 is equal to 13 pi over 4. Take this other side. So x is equal to 13 pi over 4 minus pi over 2. That is 4 down. 13 pi minus 8 pi, which is 5 pi over 4.
Excuse me, sir.
Oh, I've done the wrong thing there. It's supposed to be.
Excuse me, sir.
Hello.
Oh, yes. I wanted to say it's supposed to be 2 pi, not
Okay.
8.
So it's 2 pi, so we get 11. 11 pi over 4. Now, is 11 pi over 4 between 0 and 90. Let's check. 4 into thingy is 2 point something. So it's beyond, meaning that the angles in the third quadrant won't make sense here. So work with the angles in the first quadrant. So I got 45. How we left 45 is what I don't know. Okay. So that we are right. So what we are dealing with is, first, we said 45. After subtracting, it never gave us what we wanted. So what we'll do is, we'll get here, go around, and come back there. So it will be 360 plus pi over 4. So we'll get 8 pi plus pi, which is 9 pi over 4, and get x plus pi over 2 is equal to 9 pi over 4. So what is x? 9 pi over 4 minus pi over 2. That is 4 down, 9 pi minus 2 pi. This is 7 pi over 4. This angle is, it's where? This angle is bigger than the guy that I'm looking. Hey, this angle should be bigger than pi. It's 1 point something pi. So it's bigger than pi. Okay, let's go in the other one. In the third quadrant, where we get 225. So we'll say x plus pi over 2 is equal to 5 pi over 4. This should be 225. So x is equal to 5 pi over 4 minus pi over 2. That's 4. 5 pi minus 2 pi, which is 3 pi over 4. This guy is within what is within the interval given. So x is 3 pi over 4. So I found one. If we go around, we'll be outside the required circle. And so in the first quadrant, I mean between 0 and pi, so far this is the only angle that I've seen that will make sense. So unless you have questions. Okay. We also have question 7. For values of x between negative pi over 2 less or equal to x less or equal to pi over 2. Y is equal to half, which is 0.5 minus sine x. Sketch the curves on the same axis. Is another curve y is equal to half, half plus cos 2x So you must sketch on the same axis. So first, let's start with this guy here. The normal sketch. The sketch of y is equal to sine x. Remember that the shape here is normal. Like it becomes, it looks something like this. That's how it looks. So now this one is shifted. So we can decide to ignore the shift by using a table so the table can do the shift for us. By the way, every time you're asked to sketch sine, the first thing that you should know is, so now I want to sketch y is equal to half minus sine x. So you must first know the period. The period, if you are given a plus, if you are given a sine bx plus c plus d, what is our period? From there, we say the period is 2 pi over b, and the vertical shift is d, horizontal shift calculated by saying bx plus c is 0, and then the amplitude, we get the modulus of L. So in this case, our question is half minus sine x. So the period is 2 pi over 1, which is 2 pi. The vertical shift is half, and the amplitude, the modulus of -1, which is 1, and then there's no horizontal shift. So I was going to use the table if there was enough time. Now we only have 5 minutes remaining in the 40. So for this one, we'll use the scale, and then in the next one, where we have 40 minutes, we're going to do the one for the table. So we'll have 2 varieties. So the first one, I first get from 0. Since I'm doing 2 pi, I always break my period by 4. So 2 pi by 4, I will get pi over 2. Because we have 1, 2, 3, 4 critical points in the normal shape of sine. That's why we break the period by 4, so we can know those critical points. So, meaning from 0, we'll go to pi over 2, we'll go to pi, to 3 pi over 2, to 2 pi, the period we end there. And then we'll get back to the question which says we must sketch between negative pi over 2 all the way up to pi over 2, meaning that here we also have negative pi over 2. Now understand that sine, this one has the amplitude 1 to -1, and the vertical shift of half. So it's adding to 1, it will add half, and here it will add, so we'll go to -half. So the normal one is supposed to go from here all the way up to 90, come down. From 90 all the way up to there, go down. But it has a shift where it says each point must go up. Each point must go up. So this will be half from 0. And each point must go up. That will be -half. So it's going to be something like this. And this is the graph of y is equal to half minus, no, since it's minus, so I haven't taken care of the minus. So since it's minus, supposed to be, so now we apply the minus. So I'll use the, which ink do I use for the minus? This one. So when it is minus, this guy from -half, it will go up to the maximum. From being minimum, the midpoint remains the same. And from being positive, meaning from being maximum, it will come to minimum. So it will be to be this way. And then this way. Yeah, so what will be our graph is not this, but this one. Undo. Okay. But this one, y is equal to half minus sine x. So I'm going to explain more of the properties of sine cos graphs, the positive and minus, in the next lecture. Meaning, just after this, now we are cutting because of the Zoom that you're using. We're using a 40 minutes Zoom plan. So when it cut, you quickly join back so that you can continue. So we'll just wait maybe for a minute and then carry on. So if you join late, you'll be behind. Please just come back quickly.